Okay, so we now move on to part C, and I'll explain that. We'll just scroll up here. So for part C, we've got to explain with reference to the graph why an increase in the number of values improves the accuracy of the approximation. So I'll just leave you to think about that and come back and see if your explanation is similar to what I give. Okay, welcome back, and let's see how you got on. Well, I'm going to just draw part of that curve again, and so I'm just going to draw my y-axis and an x-axis, okay, like so, and just going to pick up the curve where it came in from 1. So we had, and I'm most probably going to exaggerate the curve here to bring out the point. So just sketch that curve in. We have quite a big curve, say something like that. And we are integrating between 1 and 3. So if I mark in that, say, as 3, it's not drawn to scale. It's only really here just to illustrate a point. So I'm going to put in the first strip that we did there, and we'll go from there up to the curve, like so. Okay, oops, just rub that out. Okay. And then what we did was, in the first instance, we worked out the area of just the two trapeziums, here and here, and what that was doing was estimating the area contained between the trapeziums. So that's meant to be a straight line. I know it's come out a little bit curved. Try again. Okay, up through here. Okay. Now you can see that there's quite a little bit of airspace here and here to the curve. So with two trapeziums, this is an overestimate to the area underneath the curve. However, by increasing the number of strips, so if I put in, say, a dotted line somewhere down here, when we did that strip, and we did the strip for when x was 2.5, okay, we created 1, 2, 3, 4 more strips, and if we were to join up from here to here, and then from there to the 2, and 2 to the 2.5, and 2.5 to the 3, hopefully you can see that the tops of these trapeziums are closer to the curve, the red curve, and so they get closer to the area underneath the curve. So therefore, the more trapeziums, or the more intervals that I create here, the closer that the area of the trapeziums gets to the area of the curve. So what I'm going to say then to answer this question is something along the lines that by increasing the number of strips, okay, by increasing the number of strips, just bear with me as I write this, the number of strips, number of strips, okay, or intervals, what have we got? That the areas of the trapeziums, okay, tend towards the area under the curve. Okay, so by increasing the number of strips, the areas of the trapeziums tend towards the area under the curve. Okay, so hopefully you've got something along those kind of lines, and maybe a diagram just to try and illustrate that, and if you did, give yourself 1 mark. There you go. For part D, we've been asked to show that the integral between 1 and 3 of x minus 1 multiplied by the natural log of x integrated with respect to x is exactly 3 over 2 multiplied by the natural log of 3. And if you do this, it's worth 6 marks. Okay, just pause the video if you'd like to have a go and come back when ready, just to check your methods and see if you've got the right answer. Okay, welcome back. Let's have a go at this. Okay, so to prove this, okay, what I'm going to do is just copy down the integral again. You should have noticed that this is a typical question that involves integration by parts. We have 2 different types of functions being multiplied together, and typical candidate then for integration by parts. Now, if you're unfamiliar with integration by parts, then our tutorial on this should hopefully help you to do this type of question. Okay, what we've got is then that when we're handling natural logs, make this the u and this the dv dx. So this is the part I'm going to end up integrating, and this is the part I'm going to end up differentiating. Okay, so according to the formula, it's uv, so that will be the natural log of x, and I always think you should write everything in brackets, so that's the u part, and v is the integral of x minus 1. By looking at the chain rule, this is the inverse of the chain rule, it would be x minus 1 to the power 2 all divided by 2. Okay, so if you were to differentiate this by using the chain rule, you would get x minus 1. Okay, then it's minus the integral of the part we just integrated, which is this part, so I'm just going to copy it straight in, so that's x minus 1 all squared, and that's divided by 2, and we multiply this by du dx, the differential of the part here, the u part, natural log of x. Differentiating natural log of x is 1 over x. Let's just put that in brackets, and it's integrated with respect to x. We've got limits here between 1 and 3, so I need to put some square brackets around this, and so it's integrated between the limits 1 and 3.